welcome everybody. Welcome to the Tech Equipment YouTube live stream that we are presenting here today on the 29th of April. My name's Dion Knowles and I am the marketing manager, and joining me today I have two people. I have the familiar solid guru that is Dave Giddings, hashtag Digital Dave. And Dave will be joining us very soon to answer questions, technical-based questions about practical teaching, whether it might be about actually using a piece of equipment, about an element of theory, anything like that. Post them in the comments box, in the chat box rather. If you're watching this on demand, you need to use the comments box below and we'll come back to you. If you're watching it live, you need to use the chat box and we'll get Dave to answer those questions. But I'm really, really excited because today we've got a guest speaker online. We have Judy live from her home office in London. You're in London, aren't you, Judy?
Yes, that's right, yes.
So Judy Raper is our guest today, and she is from TEDI-London. She is the Dean and CEO. Judy, if I can hand over to you for a moment and let you introduce yourself and a bit about what your institution is all about and what you're trying to achieve, that would be wonderful.
Okay, Dion, I'm happy to talk to you and to everybody. And I guess about myself, I'm Australian. I've been a university and academic, an engineer for 40 years and an academic for, 35 years. Most recently in research administration, but I'm delighted to have joined TEDI-London about 13 or 14 months ago as Dean and CEO. And TEDI-London is a brand new startup engineering school. So it's an engineering higher education provider. We're starting from scratch, but we have three very significant and internationally renowned founders, and they are King's College London, the University of New South Wales in Sydney, and Arizona State University in Phoenix. And the founders have worked together on a research alliance for several years, and they decided that we really need to develop new engineers, future engineers who are T-shaped, have the depth of discipline at the bottom of the T, but also the breadth of having essential skills that we can really understand how the world works and how the services and products that they design are implemented. And that's what we're trying to do with TEDI-London. We're trying to develop engineers who are going to be globally focused and socially aware.
Brilliant. Great. Thank you very much for that, Judy. Now, you mentioned project-based. How does all of that really work in terms of actually learning stuff?
So we want to disrupt engineering education. We feel that we produce very good engineers, and we've done that for 100 years, but there are several things missing. We need to increase the diversity of students studying engineering. So that's one thing. We need to have engineers, as I said, who have some skills that we aren't teaching very well at the moment or aren't developing very well. And they're sort of skills of collaboration and teamwork, understanding how society will use the products that we design, and making sure that we can implement the great technical solutions that we develop. So we feel that we can do this by the way we teach. It's not just what we teach, but the way we teach it, and the pedagogy of teaching students through making things. Engineers make things, so we're going to have our students are going to make things from day one. Actually, we're not calling them students, they're professionals in training, because the projects that they'll be working on from day one will be co-developed with industry. So they'll be real from day one, and they'll make a difference to society whilst they're still students. So it's really important that they're doing real projects and learning while they're doing them. Now, of course, you will say, in order to make something, you need to know something. So how are our students going to know anything? And the way we're going to do that is just-in-time education. So instead of having lectures and labs and assignments just in case you might need it sometime, our students will have access to a learning tree, which is an online gigantic computer game, but it's a series of 3-hour nodes that they can access when they need it. The nodes will have assignments and lab work for them to do and theoretical material for them to go through, but they'll be contextualized by the project that they're working on at the same time, so that they'll be more engaged and wanting to solve those problems. That's the theory anyway.
Brilliant. That sounds that sounds really inspirational. It sounds really exciting, and I would be really interested to hear what the opinions of people who are watching today, joining us live, what they think, what you think that, where might it be challenging. I think Judy will come on to talk later about the kind of students or professionals in work that you will be bringing onto the course. But we'll come back to that in a few minutes, if that's okay. What we're going to do now is we're going to switch over to, if I can get my diction right, we're going to switch over to Digital Dave, who is in his home office as well, like all of us. Digital Dave is here to answer your technical questions. If you are watching live, then do put them in the comments box, chat box rather. There are two different chat box, and Digital Dave will get right back to them to you. Hey Dave, how are you today?
Fine, Dion, all well and good. Yeah, very good in fact.
And the gate making?
The gate has finished. I've actually sent you pictures.
Oh, I should have put it on the screen, shouldn't I?
I want to stay quite humble in my achievement, but it's the best gate in the village for sure.
It can't be as good as my elephant.
No, it's not.
Have you seen how the elephant has come along? I'm going to have to show you the elephant now. The people who joined us last week, I think often Dave and I will talk about what's keeping us busy, and I've been trying to keep my 8-year-old son busy by making a life-size baby elephant. So I really do have to show you what the life-size baby elephant is looking like at the moment. That's been a week's worth of toil on that baby elephant, and it really is quite big.
Hey, there it is.
Look at that.
That's a lot of newspaper there.
It's a lot of newspaper and lots of recycling as well. Inside of there, we've got cereal packets, washing up tubs. This whole unit was made out of a fridge freezer box, and we've now run out of PVA glue. It's a problem. We have a crisis. There is a shortage, not of toilet roll, not of newspaper.
Yeah.
But of PVA glue.
You have to get onto Amazon or something.
Yeah, well, I think my son's losing interest. He wants to just get on and paint it now. So I think we'll have to start bringing this project to a close.
Fantastic.
There's been no learning tree involved in this, though, sadly, Judy.
Can't you make glue out of flour and water or something?
Well, that's true. That's true. Maybe we'll have to have a go at that.
You can't get hold of flour at the moment, though, Judy.
Oh, okay, yeah.
I'm all right. I went to the mill, direct to the source, and I have some big bags of flour, so we'll be all right. That'll be.
Well, Lorraine is bemoaning the fact that she can't get hold of self-raising flour at the moment, but I think you can use baking powder or something instead of. I'm not sure.
Yeah, if you go online, I've had to do this many a time actually, where I've gone online and had to substitute with a combination of baking powder and bicarbonate of soda, and there's little instructions of the ratio for every 100 grams or whatever of flour, and it works just fine.
Wow, you're becoming the expert.
Oh, I'm not sure about that. Anyway, talking about experts, let's get back to you, Dave, as Digital Dave. Questions today. Dave, first of all, what I'd like to do is talk about, yesterday we were very lucky because we got to talk about aerodynamics with a group of people from India.
We did.
And while we're talking about aerodynamics, Mach numbers came up. Somebody wanted to talk about what Mach numbers the supersonic wind tunnels could go up to. It would be really nice if you could explain a bit more about Mach numbers, because some people simply don't know what a Mach number is, and whether it's Mac or John or Alex who came up with it, or whether it's machine-assisted computer housing.
What you're trying to do is catch me out then, Dion.
Absolutely, you've always got to try and catch you out. Try to keep you on your toes.
Just cut to the chase. Well, all right, so starting with our supersonic wind tunnels, be it the AF300 or the AF302, it's important to realise that the learning outcomes are exactly the same on both of those wind tunnels. The difference between the two is one is intermittent, so we get about between 5 and 8 seconds of runtime. On the continuous, the clues in the title, we get continuous flow through the working section. So the wind speed is determined by the type of the liner that is fitted into the top of the working section. That working section takes the form of a Laval nozzle, where we have a contraction, then an expansion. Even with the huge vacuum pump on the 302 and the receiver and the compressor on the 300, that's still not enough alone to get up to Mach 1.8 through the section. So we have a special shaped nozzle that gives us that, ramps up the speed. So the wind speeds can be determined by the type of the liner that fits into the top. So we have a subsonic liner, a Mach 1.4 liner, and a Mach 1.8 liner. Okay, and depending on what wind speed that you want to be working at, depends on what liner that you have fitted. But perhaps it's a good idea just to explain what this Mach number is. I think most of us have heard of what a Mach number is, but it's named after an Austrian physicist called Ernst Mach, E-R-N-S-T, Ernst Mach. And the Mach number is a ratio of the speed of the object, so it could be a plane, divided by the speed of sound. So we know the speed of sound is 760 or so miles per hour. And so the Mach number is a ratio of that speed of sound underneath the speed of the object. So for example, we know that the speed of sound is 761 miles per hour at the speed of sound at sea level. So if a Mach number is less than 1, then the speed is lower than the speed of sound, and that's known as subsonic. Okay, these are key words that you'll see in dynamics equipments. If the Mach number is about the same as the speed of sound, then that's about Mach 1. Okay, so that's the difference, and that's called transonic. Now, if the Mach number is greater than 1, that means the speed of the plane is higher than the speed of sound, and the speed is known as supersonic. And then finally, if the Mach number is much greater than the speed of sound, then it's known as hypersonic. So they're the differences there.
And the speed of light doesn't come into any of this.
No way, not yet. Not yet. I think we're a few years behind that. So basically, the Mach number, it doesn't have any units. It's dimensionless, a bit like hardness testing, Rockwell, Binnell, Vickers. It has no number. Reynolds number, it has no units. Okay, so a unit is volts, V is to volts, W is to power, I is to amps. But for Mach number, it's just the value, no units. Okay, so that's basically an overview of what Mach number is, Dion.
Right. Okay.
Where it fits in our wind tunnels.
So we're dealing with Mach numbers when we're talking about this particular supersonic pieces of equipment.
Oh, for sure, yeah.
But not when we're talking subsonic.
Yeah, well, we are, because our AF 1300 or AF 1125, that runs at 36 meters per second, which is about 85 miles per hour, or 120 or so kilometers per hour. But our AF 302 runs at either subsonic, Mach 1.4 or Mach 1.8.
Ah, right, okay.
So we don't talk much about Mach numbers in the subsonic environment. It's more when we get stuck into supersonic flow on the supersonic wind tunnels. Okay,
good. Right. Thank you for that, Dave. Dave, I'm going to let you have a breather. Judy, it's your turn. So Judy, I'd like to talk to you a bit more about, yes, you've explained about the project-based learning approach. And let's pull up your website quickly so that so everybody can have a quick peek. London, is it TEDI.London?
TEDI-London, yeah.
Yeah, at ac.uk. So what we've got going on the background. Right, okay, so in here you talk about it being, industry-led, tailored learning, and filling the skills gap, but you need a particular type of person, don't you? You're not going to have
yeah, so we need someone who's willing to take responsibility for their own learning. So really, because you're going to work on projects straight away, and you've got a learning tree that is just in time learning, so you've got to have initiative to go and do it. We will facilitate it, of course. There's academics and collaborators, industry mentors as well, who will facilitate and help. So I don't want people to think that it's just students learning from themselves, but students have to take the initiative. And so the type of people we want to have are people who have an aptitude for technical subjects, for maths and science and physics, have an ability to learn, and have an attitude where they want to learn and they take responsibility for their own learning. And that's 3 A's, but not A levels. We're not looking at A levels at all. We're going to measure those aptitudes, and the aptitude and the ability and the attitude. And that's how we're going to take our students. And by doing that, we feel that we will open engineering up to a whole lot of students who felt that they haven't had the opportunity or haven't had the background to do that. And an example is last year we had a summer school, and the summer school was 3 weeks residential at Printworks at our campus. Most of the students were engineering students, but we had a bunch of business students, a dentist, a philosopher, and some other sort of, they were it. I think the business students but the philosophy student was really interesting, and we had her speak at our launch just a few weeks ago. She said if she hadn't come to this summer school and worked on a project, she would not have believed that she could do technical subjects. And now she's done philosophy as an undergraduate degree, and she's gone to the LSE to do business and finance as a postgraduate degree. And you need technical ability for that. So it shows that people don't realize that they can do it by just going through the school system.
Yeah, I think that's an amazing example that somebody that should go from philosophy to business and then embark on your project-based courses. Yeah, it really
and
is.
the project that she was involved with, she was involved in a citizen hub for Canada Water. So this project that they built was all the better because of her input as well. So it goes 2 ways. So having that input was beneficial to the engineering students as well.
Brilliant. How very interesting. Thank you, Judy. I'm going to give you a break for a moment. Now, Dave, I'm hoping you're still there. I've also muted you a second. There you go, Dave. Dave's mid-biscuit. Sorry, Dave.
Okay, 2 things then, Dion. You may have heard some background conversation there.
I muted you, sorry.
This is live.
Yeah.
2 things that I need to tell you. First of all, ask me if lockdown is working.
Okay. Is lockdown working for you, Dave?
Homemade peanut butter cookies. Okay, number 1. Number 2, I've just been asked by Lorraine, my much better half, because she's getting a dog. Okay, she's just interrupted my YouTube session to ask me, quote, how fast do you think the dog can run?
Is that Mach 1.4?
I don't know.
I really hope not.
I said about 10 miles per hour. So
can you keep up with it?
I'll keep up with you, I tell you. All right, so that was what the background noise may have
right.
heard.
Oh, well, for those who don't know, Dave is going to welcome the world of dogs into his life. The cat lover is going over to the dark side, or the better side, in my opinion, because I'm a dog lover. Sorry to those cat lovers in the world, but yeah. I think you will be all the better for it, Dave. I think, yeah, you're going to have a degree of chaos with a puppy in your life for a while, but
no, more chaos.
Okay, you've got to embrace chaos. Chaos is good if you embrace it.
Yeah. So
Right, Dave, I would like to talk to you about a video that we've shared today on the Tech Equipment channel about students that have been looking at the performance of Francis turbine, which is awesome because it's actually looking at a piece of theory, trying to understand it. But there's a slight issue, is that they've used salt water in their piece of equipment. So I'm not sure, let me mute this one moment. I'm not sure if everybody can see that right now.
Yeah.
Can you see it, Dave?
Yeah, there's a few
Brilliant.
frames being skipped.
Okay, let's
but
skip it to what we're doing here.
I can get to the bones of it.
Right, yeah, so what they've done is they're looking at different variables that might affect the performance of a Francis turbine. So they've used different temperatures of water, and they've used salt water as well. So yeah, which is interesting concept to test, but what would you say about use of salt water generally in apparatus?
Okay. Wow. No. I can speak from experience because I had a boat in a previous life with an inboard engine, and it relied on salt water to cool the engine. Look, salt water, it's a killer. Okay, it's a no-no. Just by not flushing a boat or cleaning a boat out overnight would leave tide marks and all kinds of problems with bearings, with the engine itself, with the cooling system. Deposits of salt would block the cooling pipes. It would cause my brakes to seize. It's a no-no, absolute no-no. And if they have used salt water, then I'd strongly encourage they flush as quickly as possible to remove those tide marks.
Now, I'd imagine they probably have, because they're a very competent
Yeah.
university. They've been using our equipment for a long time, and
They
they work very closely with us. So I'd imagine the professors said, yeah, you can do this, but you make sure you clean it out well, guys.
Yeah, but in addition to that, Dion, if I would assume that our digital hydraulic bench has been providing the water for that.
Yes, it has.
So equally, they need to make sure that the hydraulic bench has a good clean afterwards. So remove all those deposits and get that fresh, clean tap water into that bench as soon as possible.
Great. Okay. So the takeaway from that, everybody, is not really advised to use salt water. In fact, customer care would say absolutely don't use salt water.
I mean, I must admit, in some territories, it can be tempting. I mean, I've done a lot of work in Saudi Arabia. There are no rivers, there are no lakes, and all drinking water is desalinized water. And so salt water is so much more tempting to use but don't be tempted.
Okay. Stick on the straight and narrow with your nice clean water, people. Yeah. All right, Dave, thank you so much for that. We're going to pop back over to Judy now. You can eat the rest of your biscuit now. Make us all very jealous with your peanut butter biscuits. Judy, have you got any biscuits on hand?
I don't, but can I just say that Dave just exhibited one of the most important aspects or characteristics of a good engineer, and that's estimation. By being able to estimate just on the spot the speed of the dog. So well done, Dave.
I think Dave needs to think about the size of the dog and the different ranges as it grows up. And I'm sure Lorraine will be asking how fast it goes at 2 months, how fast it will go at 6 months. So be prepared.
Yeah. This is all new to me, the dog thing. I'm just not, I'm so out of my comfort zone.
You're going to have a shock. Let's put it that way. A good and a bad, puppies are puppies and everything. Anyway. Over to Judy now. Got a question now online. Judy mentioned increasing diversity in the engineering profession. How will TEDI approach student, i.e. professional in training, recruitment differently to traditional universities?
Well, the first thing is the different selection criteria. So don't worry about A level. We're not looking at A level. We're looking at those other A's that we need, and attitude and aptitude. So we're opening it up immediately to a bunch of students that haven't been able to have that opportunity before. We are doing traditional sort of methods like going to UCAS fairs, which we managed to go to 3 so far before they closed down. But we're also engaging with people online, and we've got a program called the 2021 Agenda, where we launched that last week, and we've called for students to think about how they can contribute to, how engineers can contribute to the big global challenges of the future, and to send us a 1-minute video or some information about what they think the challenges are. And we're going to engage with those students to help develop our curriculum and our projects. So we're going to have real projects in that way as well. So students feel that they're part of this growing community of learning. And then we're also going to have a summer school for school kids later on in the summer, after our engineering student summer school has finished, and we'll be doing some online activities. We're going to have a Dean's Digital Challenge, where we'll send out a challenge every month for people to try to do, and so various things like that. But getting out there among students, and our values involve active learning. So we'll be getting students to be doing things like your elephant project, to be actually doing things, even in trying to find out more about TEDI-London.
Brilliant. That's really, really helpful today. So when you're talking about school kids, I guess you're talking about 16, 17,
Yeah.
18-year-olds.
Yeah.
I almost thought I could send my 8 and 11-year-old your way. I almost thought I could just ship them off to London to, all this homeschooling is driving me insane.
Along with a lot of other people, I'm sure.
Yeah, but the teachers are doing an amazing job in terms of providing background support. Thank you, Judy. That's great. And on the screen right now, everybody can see the TEDI-London agenda, how you can get involved. You can put your details in there to submit your 1-minute video, which is really cool idea. So, Judy, this is the time when you can have a drink and dig out your biscuits, chocolate bar, crisp, sandwich, snack of choice. And Dave has finished his wonderful biscuit, unless he's or the packet of them, the whole bake.
No, they're homemade. We don't do packets here.
Well, maybe you've finished them all. I don't know whether Lorraine's had a look in.
They're at risk. They're in danger.
Or are you being rationed? with
there is a chance.
With that flour shortage. Anyway,
Yeah.
Dave, question for you now. Let's go back to talking about aerodynamics again. Now, we're not going to give the game away now, because we've got an aerodynamics webinar coming up next week. We'll be streaming that live on YouTube, so everybody can think of all their wonderful aerodynamics questions for then, whether you want to know about the Bernoulli's equation, lift and drag. But question, let's start it off, Dave. As a basic foundation, where would you start if you want to teach a foundation course, so mechanical engineers, for example, about the basics of aerodynamics? What would those basics be? And what pieces of equipment might you want to be using to supplement the actual lectures?
Okay, well, to start from the beginning, you need to be looking at flow around objects. So they could be 3-dimensional objects, golf ball, sphere, hemisphere, flat plate. We can look at the wake traverse caused by those models. We need to be looking at aerofoils. So we look at the lift generated by an aerofoil, the drag generated by the aerofoil, and also the pitching or the twisting of the aerofoil. These are key subject areas in aerodynamics, okay? But before that, perhaps they might want to be looking at just basic airflow. If they do want to look at airflow, then the AF10 stands out as an ideal product. It's compact. There's a range of 8 or 9 experiments that fit in the AF10, covering basic lift and drag, boundary layers, flow around a duct, flip-flop circuits, all good basic experiments. There's no data logging on the airflow bench. You, the user, are the data logger with your eyes and a notepad. So the students will be encouraged to get out their calculators, rulers, and do some maths. Okay, there's a good example there of an experiment looking at just that. Looks like a wake traverse test as we traverse across the downstream edge of the aerofoil, just to look at the turbulence that's being caused by that aerofoil. So this is the perfect starting point with alongside a subsonic wind tunnel, Dion.
Right, and that would be something like the AF 1300 or the AF 1125.
Yeah, benchtop or floor mounted.
Right, all right. Brilliant. Okay, good. That's really helpful. Dave, thank you very much for that. I'm going to hop back over to Judy now. Judy, we've had a question online, and the question is, will TEDI have an advantage over other institutions due to the way the course is delivered, bearing in mind the requirements of a post-COVID-19 world? Do you think?
I hope so. We started off, the vision was a campus experience. So even though we have a learning tree that's delivered online, the vision is that they do that on campus with their collaborating students, with industry collaborators and partners, and with academics. So originally the vision was all physical, and professionals in training were going to be expected to be on campus 5 days a week. With the summer school, the summer school for this year is trying to create technology products for a dementia-friendly community in Canada Water, and we've had to pivot and make it online because we can't have students come to campus for the summer school. So we are testing a model of online delivery that is still based on small group projects with a mentor for each project, and design thinking with stakeholder group, steering group as well. So all those principles that we would have had on campus, we're doing online. So it's going to be a very interesting summer school. I just heard this morning that we've had over 50 people expressing interest in coming, and we have to interview them all to make sure that they've got the right attitude. So it's going to be very interesting. And if it works, then yes, the answer to the question is yes, we will have an advantage. If it doesn't work, we have to think again and make it better.
Well, I think, in my personal opinion, reflecting on that, we're all learning so much about how to use technologies, like we're using Zoom and YouTube today. Everybody's adapting to that. Hopefully, they should already be one step ahead. Even kids at school are having Zoom lessons, so they should be familiar with how to focus and engage with people online, which hopefully should make your summer school a real success. We'll be definitely watching out for the progress on that, and hopefully you'll come back and tell us more about how things are going.
Absolutely.
Brilliant. Okay, thank you, Judy. I think we'll hop back over to Dave now.
Yep.
Dave,
Yep.
My question to you would be about the supersonic wind tunnel range.
Yeah.
When we've got two main supersonic wind tunnels, and people are a bit confused about which one they should use, what the differences might be. I wondered if you might be able to tell us a little bit more about when might you use one over the other, for example.
Well, working backwards, Dion, the learning outcomes for both wind tunnels are exactly the same. Okay, we can look at pressure distribution along the nozzle, along the Laval nozzle, or working section, in other words. We can look at airflow, supersonic airflow over two-dimensional models. So they could be 5 degree, 10 degree, 7 degree tapped aerofoils that sit within the small working section of the wind tunnel. And it's the same for the AF 300 as it is for the 302. It's exactly the same, okay? The only difference is, like we mentioned before, is with the intermittent, the clue is in the title, you get between 5 to 8 seconds of runtime. Why is this? Well, that's because we use a compressor and 2 or 3 receivers to force the air through the nozzle, through the working section. With the continuous, well, there's a bit of a clue there also. It uses an extremely large vacuum pump, a huge vacuum pump, and it sucks air through the working section, and it will carry on, not indefinitely, but it will carry on until you hit the off switch, the power switch. There's a big difference, I would expect, in the price, but all I know is about the functionality of those two, and the outcomes remain the same.
Right, so the difference is carrying on continually being able to do experiments, but you've got this great big piece of kit that you need to have.
Very good.
That. Versus slightly more compact. Well, not necessarily physically compact, but it doesn't require such an intensive piece of equipment that sits behind it with the pressurized tanks for the other one. But you have to run in spurts because you've only got so much kind of air to work with.
Now, ironically, the 302 continuous is actually much easier to run than the 300. I can actually run a 302 on my own because it's continuous, so I can concentrate on what's going on in the working section without concerning myself, you know, how much air have I got in the tanks. That's purely irrelevant because it just carries on and on. Whereas the 300, you have to be mindful of the delivery pressure coming from the tanks. So that's where the 8 seconds comes from. You can get over that by using VDAS, which is TEDI's proprietary software, when you can do a timed recording, so you don't have to worry about missing any of the data. Then you can go back later, dump it into Excel, delete the unnecessary lines of data, and be left with the pure interesting data.
Right, brilliant. All right, well, we'll be telling you more about the aerodynamics in our webinar coming up next Thursday. Do look out for that on YouTube and click the little reminder bell. That means that when we go live, you get a little bell and it tells you we're here. Come and join us, come and ask your questions. Now, that's it pretty much from us today. Dave, thank you as ever for being our resident guru. But I really want to say huge thank you to Judy for joining us today. Thank you, Judy. It's been an absolute pleasure to hear about your new transformative engineering education approach. Really looking forward to seeing how this progresses. Can you remind us what those degrees are? Because it's not a massive course range that you're offering.
We're looking to have global design engineering at master's and bachelor's level. That's what we're aiming for.
And that's starting next year, 2021, isn't it? You're taking your intake. Brilliant. So any, I guess, 17, 18, 19-year-olds out there want to start thinking about this, but you're not just taking those traditional people, are you? You're thinking wider.
Anybody, you know, people that are mature and never had the opportunity, or even if you're an engineer and you want to train in the modern world, it is a great opportunity.
Fantastic. Yeah, so again, thank you, Judy. Go check out the TEDI-London website. It really is quite interesting, and they've got lots of stuff going on in their social media as well. Maybe create your little 1-minute video and post it on there for their 2021 challenge. Thanks again, Judy. Thank you, everybody, for joining us live today, asking your questions. It's always a great pleasure. If you've got more questions and you're watching this on demand, then you can use the comment box below, put them in there, and I'll feed them back to Dave and to Judy, and we will get responses to you within quick time. Okay, so thank you very much.
Okay,
this is us for today. Thank you, Judy. Thank you, Dave.
Bye now.
And goodbye.